Thank you so very much for that wonderful introduction. I'm so excited to talk with you all today and tell you a little bit about what we have been doing over the past year at JetBlue and how we have really took off with DBT. So, as mentioned, my name is Ashley Van Name. I'm the manager of data engineering at JetBlue. I'd also like to take some time to introduce Ben Singleton. He is my manager and the director of data science and analytics at JetBlue. Ben has been absolutely instrumental in every aspect of this project that I'm going to be talking about today. He's also super active on the DBT Slack channel, so you may or may not have virtually met him in some of those posts on there. I would say I had been working with JetBlue for just over 3 years, and I've seen a lot of transformation happen in the data space since I joined the company in 2017, much of which I'm really excited to share with you today. But that's enough about us. I'm really here to talk about what we've been up to and what our team has been working on, so I'll jump right into it. In mid 2019, we set out to answer a seemingly easy question. The key word there is seemingly. What should a data driven airline really look like today? We like to think of JetBlue as a data driven airline. We are, of course, the data engineering team, but we really wanted to pinpoint specific projects and use cases that we really thought a data driven airline should be working on. So we came up with a really long list of things that we thought a data driven airline should be focusing on, one of them being offering personalized customer interactions. So at JetBlue, we consider all of our customers to be really special and unique, and we wanted to treat them in that way. The best way to learn about our customers and their behaviors is by ensuring that their data is securely stored and accessible by business units who can then build data driven processes to improve the customer's experience while they're traveling with us. So overall, to do that, we just needed a whole bunch more data. We also wanted to do things like predict delays and other irregular operations that may occur during the operation of a flight. So no one wants to be on a flight that's delayed, makes a return to a gate, or probably even worse, a diversion to another airport. Our analysts needed access to more data to be able to build out predictive models. We also wanted to focus on enabling all analysts to easily access a variety of different data sources. So, you can set out a goal to say that you want to store every piece of data that your company can possibly capture in your data warehouse. But if no one knows how to use any of that data, it essentially becomes worthless. We wanted to ensure that analysts not only had a way to access the data they need, but also were able to understand the data that was available to them. We needed a lot better documentation. And lastly, we wanted to study and monitor operations in real time to make smarter decisions. I think I can speak for almost any business when I say accessing real time data and information enables you to make better decisions. This is not anything that's new. So, while we did perform analyses and have some reports that pulled from real time data feeds internally, we didn't really have a system in place to make that real time data available to everyone. So that simple analysis helped us to understand we really couldn't consider ourselves to be a data driven airline just yet. We weren't quite working on the projects that we thought a data driven airline should be working on. So then our next question was like, okay, how do we actually get there? What are the principles that we should think about when trying to convert our company to be more data driven? The first one is that we wanted to make sure we were consulting data in every decision that we make. So, decisions really shouldn't be made with gut feelings. They should be backed by data, ideally pulled from your enterprise data warehouse. If an analyst walks into a meeting to give a presentation on a new corporate strategy, they should probably have a slide in their PowerPoint deck that contains a graph that was generated from data in our warehouse. Ideally, that's how it would work. Oftentimes, airlines themselves are described as sort of an orchestra. It's a gigantic system of all these different players that need to work together in perfect harmony to get a plane to move from one place to another and get passengers to and from their destinations. So things people like dispatchers, fuelers, pilots, airport operations, customer support, you name it, every piece of the operation needs access to data and needs to consult data in their day-to-day work so that we can actually ensure that customers get where they want to go when they want to go there. Next up, we wanted to make sure that we were enabling self-service analytics as best we could. So again, like your data is really only as good as your team's ability to understand it. So on a high level, training and documentation is a must. At JetBlue, some groups actually have their own data analysts that specialize in their own team's data domain. And these teams become SMEs in one single part of data that's stored in our data warehouse. But other teams, they may not have analysts that are super technical. They may not be able to query a data warehouse using SQL. And so we really wanted to focus on harnessing the analytical power of those people and train them in a way that they can grab the data they need from the data warehouse. Lastly, we felt that data engineers should be able to build data products as quickly as our business grows. So while this principle may be a little bit more relevant to startups that might be growing at exponential rates, it's also super relevant at large corporations like ours. At the end of the day, when any analyst comes to the data engineering team and asks for a data set, your engineering team should be able to deliver it for them. So, with all of these things considered, we realized that our legacy infrastructure could not support us becoming more data driven. We needed a platform that could enable us to do all these really cool things. And so we spent most of 2020 building out our base, building a new data platform, including DBT, to hope to achieve these goals in the future. I put this meme on this slide because I think that every day I wake up thinking I want to get more data to more people every day. And so Oprah, I guess, is my spirit animal. So what did this journey actually look like for us? We went from zero to DBT in just about 6 months. In that time, we built 1,800 models. Half of these models were built to match data tables in our legacy systems, while the other half were completely re-engineered in a brand new data model. On top of that, we built over 7,900 schema tests. This helped us to test our source data and our clean data models, which is something that we really didn't have the ability to do before, at least at the scale that we wanted to. We pulled this data from over 37 different data sources. So these included things like real time feeds, daily batch files, ad hoc data files, you name it. And it ends up equating to about 360 source tables in our raw database in Snowflake. And we did this with 34 contributors to our DBT repo. So even through the ups and downs of COVID-19's impact on our industry and everything else about our lives, the team was able to keep pushing forward. And I'm so proud of them for all the work that they've been able to do in this short period of time. This is a team that didn't know what DBT was in 2019. So I think that kind of just speaks to the scale and what we were able to achieve over the short period of time. So, to give you a better sense of where we started and how you can sort of think about our legacy landscape and how it might compare to yours, I'd like to give a few bits and pieces of what our analysts' experience used to be like at JetBlue when in terms of dealing with data. So the way that we identified what these problems were was that we sent out a survey to analysts across our company. We wanted to understand what are their pain points, what are their frustrations, what issues did they have while consuming data at JetBlue. And their responses kind of took on four main categories. The first one being challenges with finding, consuming, and understanding data. So they felt that documentation was sparse and hard to find. Analysts didn't necessarily know what data existed, where it existed, how they could access it if they needed it to do their job. On top of that, engineers, especially in IT, had a hard time understanding the meaning behind some of the data that they were tasked to maintain, which can also become a problem because when issues eventually come up, they had trouble sometimes troubleshooting why the issues were occurring. Also, our data transformations occurred in what I like to call the black box of SSIS in our case. Most of our ETL code was stored in gigantic SSIS packages that were really hard to navigate, especially for someone who didn't build them themselves. Analysts also had virtually no insight into these transformations. If anyone wanted to see what SQL script we were running to make a table into something in our data warehouse, it took a lot of coordination with our engineering team to deliver the analysts the information that they needed. The second pain point was database availability and query performance. This was not something that we realized through our survey. This was something we knew existed early on. Our data warehouse, our legacy data warehouse, operated like a part-time employee. It's actually really sad. We only had a warehouse available for a portion of the day for querying because we needed to lock out analysts from looking at any of that data from 11 p.m. to 9 a.m. every day while our data loading jobs were happening for that day. So that meant that reports couldn't run, analyses couldn't be done. It really was just useless during that time period because we couldn't gain any insight from the data stored in that data warehouse. When the data warehouse was up and running, queries were pretty slow. Our data warehouse supported 32 concurrent queries. So if at any point an analyst, more than 32 analysts wanted to query data, the queries would eventually queue and query times would be really slow. Analysts also voiced their concern that they didn't have access to real-time data. We're an airline. If you open up google.com, you can type in any JetBlue flight today and you can see real-time positioning information. You can see what time the plane left, all of these types of data points that just weren't available to our analysts in real time in our data warehouse. All real-time reporting needed to be built and supported by IT, which is a significant bottleneck. We also had some data security limitations, which meant that we couldn't fully democratize data. We saw opportunities to incorporate more sophisticated data masking techniques, which would enable us to eventually share data with more analysts in a secure way. And the last pain point was that we had a lot of IT bottlenecks. So our data engineering team is really quite small. We are a strong team, but we just weren't able to keep up with the demand for new data tables and reports that were coming to us from the business side of the house. So if you believe that a data engineering team should be about 3 to 5% of your total company size, that would mean that our team of data engineers should have been over 600 people strong. We have less than 30. So I think that gives you a little sense of scope of sort of what we were dealing with and the demand that we were trying to keep up with. And on top of all of this, like with every product we would build out, engineers started to become SMEs in the data. That actually might not sound like a problem, but it sort of is, right? Because if analysts rely on engineers to not only build data products, but then also teach them how to query and understand the data, it puts additional constraints on how many products your engineering team can actually push out to production. So overall, we knew we needed to make a few changes, and we decided we needed to invest in a new data stack in order to fix a lot of these problems. So that's exactly what we did. We invested in a new data stack. We went from the world of ETL, extract, transform, and load. All of our data used to be stored and archived in shared folders that were then picked up by gargantuan SSIS packages and loaded into our legacy data warehouse, which is called the Analytics Platform System, or as we like to call it, APS. We completely turned that stack on its head. We invested in Azure. We brought on Fivetran. We have Snowflake and dbt. Those are our core products. JetBlue had already previously invested heavily into Azure, and so we needed to pick a stack that would work nicely with that landscape. That also explains our Azure Data Factory pipelining choice. There's also another side to this stack, which I don't necessarily have pictured here, but I just want to bring your awareness that it does exist, and that's our real-time data stack. So at JetBlue, we have essentially two data engineering teams, one that focuses primarily on consuming and providing real-time streaming data using a full Java stack, and the other that focuses on analytics. That's the team that I work with, and this is our analytics data stack. But there is a real-time piece of this puzzle that's probably deserves its own talk. So, what exactly happened when we invested in this new stack? I mean, we saw some immediate benefits. First off, increased database uptime and query performance improvements, right? So, instead of our data warehouse being down for multiple hours per day, now we had Snowflake that was up and running 24/7, that also had separate warehouses for data loading, transformation, and analytical queries, which could also help to provide better query performance for our end user. We were also able to build out simpler, cleaner, transparent data transformations using dbt, which allowed our engineering team to build tables and views in their warehouse much quicker than they could before. And on top of that, we also purchased dbt Cloud, and we host our dbt docs site within dbt Cloud and distribute everything, the docs and the source code, to our end users, which helps to remove that black box around data transformation that our analysts used to complain about. I'd like to also specifically call out that choosing a new data stack is definitely not an easy task, especially at large organizations. you really need to think about, how will the product scale? How will it perform? Will it meet your needs? Well, all those are great questions to ask. It's really, really extremely difficult to get exact answers to all of those questions with 100% certainty. And so we made a few bold choices based on the type of data stack that we saw many smart companies moving towards. We sort of figured if it worked for them, we could probably make it work for us. And we were able to accelerate our timeline in development by taking a chance on our new data stack, and it proved to serve us well in the end. So, what now? We have this new data stack that we're marching towards implementing. What do we actually do with it? Do we write code? No. I think this was probably my face when I heard that we had all these new great tools available to us. I was really excited to start coding right away. By going through the process, I can easily say there is a lot of necessary pre-work that you should consider before you actually start putting your fingers on the keyboard and building out DBT models. This pre-work will help to keep you on track, and we call this our transition plan. So if you're thinking about building this out at your company, I would take these 5 steps sort of as guidance and advice, and that's why I highlight them in this presentation, because I think some of this pre-work can sometimes get lost in the wings when you're getting excited about implementing a new technology at your company. So the first one was pretty simple, right? We wanted to define an ultimate goal. What did we want to get out of this entire project of moving our old warehouse on premise into the cloud, into Snowflake? Well, our goal statement was exactly that. We wanted to recreate our existing data warehouse in Snowflake using dbt. We wanted to keep in mind that all design decisions should be made with the analyst pain points in mind. So we performed that analyst survey in the beginning for a reason. We wanted to take their responses forward and ensure that we weren't going to bring bad practices from the old data warehouse into the new one. We also wanted to ensure that we sort of begin to think about our data warehouse as a product. It should be well designed and intuitive. Data warehouses, at least at our company, were sometimes thought of as junkyards of data rather than like a sleek, clean product. And so we needed to think about and spend a little bit more time in considering how the product should be designed and how it should be used by the end user. The next step was for us to take an inventory of our existing warehouse. So at an extremely high level, this means creating a list of tables and views that should be moved into your new data warehouse. This can be considered sort of like your master list of work. Missing an element here can certainly come back to bite you in the end. We are learning that the hard way. So take your time in this step if you go through this process as well. And while going through this process of inventorying, you should also take time to consider, which objects do you actually need to move from your legacy warehouse into your new one. A lot of times there are bits and pieces and tables and views that aren't necessarily used by anyone anymore, and there's no need to spend your engineering time and effort in bringing those over into the new world or new data warehouse if no one's really using them. Super important to evaluate all upstream and downstream dependencies. This is actually one of the harder parts of this whole transition plan, right? You can run database traces on your data warehouse, your existing one, to identify processes that are dependent on the data in your warehouse, but you also can sometimes run into this issue with what we call shadow IT. So in some organizations like ours, business units outside of IT have built out applications, scripts, and reports, etc., that depend directly on the data warehouse. All of these things for us needed to be moved to Snowflake, and sometimes we didn't even know they existed. Step 4 was that we wanted to entertain value add conversations. So what I mean by this is, really think about how you'll convince analysts to migrate to this new platform. For us, we found that implementing and introducing them to additional capabilities that they didn't necessarily have in the old platform got them really excited and sort of lessened the burn of them having to maybe rewrite a few queries in the process of transitioning. We also spent a lot of time thinking about how we'll sell the capability of the product and not necessarily the technology. So I know we're probably all data geeks at this conference today, but not everyone will get excited when they hear the term cloud data warehouse. They might not even know what it means. But those same people might get super excited if you tell them about what new data sources their team will have access to and what new types of reporting they can build out based on that data. And lastly, part of the transition plan should be to really focus on communicating to end users early on. Platform shift is often seen as a burden, especially for analysts. When they need to rewrite queries or change the program they're using to get data, they're often aren't very excited to do that sort of thing. And so if you communicate with them early, it gives them enough time to transition their own work into Snowflake in our case and kind of prepare for what's next to come. Another thing we did at this stage was we set up a communication work group. So your communication strategy should include regular briefings, project updates, a repository of reference articles, and regular training for analysts at your company to get them ready for the transition. These activities take a really long time, and I would consider setting up a group that can share these tasks. So it shouldn't just be one person who's responsible if you have a large company. Ideally, these tasks should also be completed by someone outside of the core engineering team because you want your engineers to be able to focus on writing code, not necessarily writing up documentation. There were a few more preliminary decisions and actions that we took before putting our hands on the keyboard and writing DBT code. So the first decision we made was, okay, do we do a lift and shift from our legacy system or do we just code from scratch? We decided to code from scratch because we simply wanted to relearn a lot of our own processes and also simplify a bunch of our complex transformation that existed in our old SSIS packages. So that was an easy decision for us to make. The next decision we had to make was, okay, do we move to a new data model? Do we keep the old data model or do we have both available for our end users? We decided on both. We actually built out a really clean, sleek new data model, and then we built views on top of that to cast the data back into the old data model that matched the legacy system so that analysts were, the only ask we were giving to analysts was to move to the new platform, not necessarily learn a completely new data model in the process. We also spent a lot of time on training at this step. So our engineering team attended DBT Learn, which was awesome and great. And we read up on a lot of the best practices on DBT Slack and the documentation site. Really just think that planning your training early is the best way to get your team ready for the transition and get over the learning curve. And lastly, we adopted a set of project and coding conventions directly from the start. So in looking at a lot of our legacy code, it was written by many different people over many years. And while there were some standards in place, there weren't what I like to call hardcore standards that never differ from package to package. And so we picked out for DBT, we picked out a style guide, a SQL style guide, and we also made a few project conventions and rules, mainly that all of our models needed to be documented with YAML files, markdown files, and tests before we could push it into a higher environment. So with all of this pre-work done, we then needed to ask ourselves, well, how long does this kind of transition take and how long should it take? We hired a consulting company that originally gave us a 3-year timeline on this sort of project to move all of our data tables and views from our legacy system into Snowflake. We said, okay, thank you, but we're going to try to do it in a year. And that's what we did. I'll preface this by saying that this timeline is a bit illustrative, only because there were some pieces of the pre-work that happened in late 2019, but more or less this maps to our actual timeline. So in Q1 of 2020, we really focused on creating a vision, securing funding, and purchasing products. So this included our company-wide survey of analysts. We also worked with management to identify our visionary goals and get the business case approvals. We worked with our vendors to make sure that we were able to actually purchase their products, and we worked heavily with IT security to gain clearance and guidance on how to implement the solution at our company. In Q2, we started coding. We identified what needed to be built. We wrangled our historical data from raw data files and also from our legacy system when we didn't have raw historical files available. We trained the team and we began writing DBT code. On top of that, we also started our communication plan with end users and let them know what was coming. In Q3, we coded more. We focused on dbt modeling and ingestion pipelines. We came up with a system to test our data in the old platform against the data in the new platform. We wrote up documentation for users. And we also partnered with a few tech-forward business units who were able to give us feedback and help us improve upon what we had already built out in Snowflake. We called this our private preview phase, and we think that it was a really cool thing that we did in this project and helped us to get a lot of really great feedback. In Q4, we are finishing up all of our testing on our data sources. We're pushing forward to the end of the year. We have currently the team under-allocated on development work and over-allocated on addressing things like having to convert queries for business units that were not necessarily fully ready for the shutdown. We're also focusing on demos and doubling down on our communications to make sure everyone is aware of what's coming up in the next couple of weeks. I'll end with saying that like this timeline was super, super aggressive. Our sheer work ethic alone probably couldn't have gotten us where we are today. And we credit a lot of this timeline to Snowflake and dbt, which were two products that made it super, super easy for us to quickly build and scale out our data modeling work over this past year, even with coronavirus. So then we come to the challenges, right? So while things were really easy for the most part, there were also some really difficult things that we had to face. And I wanted to spend some time talking about them because I think that they will probably be faced at other large organizations that try to do the same type of thing that we did. So the first major hurdle that we hit was around wrangling raw data. We decided to process all of our raw historical data from scratch. We took our raw data files, loaded them to Snowflake, and applied our dbt models on top of them to expose data to analysts. In some instances, we didn't actually have all of our raw historical data files. Some historical data was only available in our data warehouse. And so for us, this meant that we needed to actually rent an Azure data box, ship it to our data center, ask the data center engineers to hook the data box up to our server, copy data over onto that data box, and then send it back to Azure so that they could upload it into the cloud for us. This is an extraordinary amount of coordination to just get that historical data into a place where you can use it eventually in your dbt models. Once you grab all this pre-transformed data, then you need to think about how you'll actually union that data to your raw data that you're getting every day in these raw files. We did this by creating two separate models, one that would expose the pre-transformed data that we pulled from our legacy data warehouse, and one model that was essentially our nice, new, shiny dbt model that pulled raw data from our raw database and materialized it in analytics. We union the two together to create a complete data set for our analysts. So the next really big hurdle that we had to deal with was testing data between these two systems. It's really easy to compare data between two systems with a simple script. We did this with Python, and that really was not the hard part. The hard part was digging into the discrepancies that ultimately occur between the two systems. Figuring out root cause takes an extremely long time and a lot of effort from the engineering team. So I would just say in this, if you opt to load all of your historical data from scratch, you're probably bound to find some discrepancies in your testing that are actually due to your new data warehouse having better quality data than your old data warehouse. And we saw issues like records that were missed in our old data warehouse due to files that contained special characters, instances where our legacy data loading job failed and we didn't really know about it, and so there was just some missing data in there. We also found instances where we had bugs in our logic in the old warehouse that we then fixed in our dbt models. But all these things combined sort of just made the data, it made it hard to compare the data between two systems. So I would just say, make sure to allocate enough time for data testing, bug fixing, and retesting. Third, we we really needed to ensure that we had processes in place to address issues that come up in the ingestion phase of our data loading process. And we also wanted to make sure that we have run books in place so when issues do occur, our engineers are able to troubleshoot them if they didn't specifically build out the process themselves. And so while you're moving a mile a minute in developing new data models in DBT, it's sometimes easy to forget about this sort of documentation that also needs to exist to keep your business up and running and ensure that you have people that are able to troubleshoot issues ultimately when they come up. And our last hurdle was sunsetting the legacy system. So we haven't actually quite done this yet. Our legacy system is still up and running at the moment, but we found that this piece of this project has become sort of a mini project within itself. We're already tracking it as a separate project plan so that we can ensure that all steps are taken to properly turn off that legacy data warehouse. That project plan should include things like what jobs need to be turned off, how will your data in your legacy warehouse be backed up. And also, as a part of this process, we're finding that no matter how many times we communicate and send out blast emails, there are always some users and some teams that didn't know the legacy warehouse was going away and need help in converting their queries at last minute. So all these things considered, these were hurdles that sort of slowed us down along the way. And I wanted to call them out because I think our experience here, we kind of learned the hard way on some of these things, and hopefully this advice can help others in the future. Above all of these things, I would just say to expect the unexpected. I put up a few pieces of our data stack that caused us a bunch of headaches as we were trying to build out this implementation. So I won't go into all of these in detail, but just know that I'm sure whatever your implementation looks like, you're going to have issues where you weren't expecting your data stack to perform in a certain way that it did. And you may spend 2, 3, 4, even 6 weeks trying to figure out how to get to a resolution on these things, and they can certainly slow you down. So now I want to spend a bit of time just talking briefly about what our DBT project actually looks like. This is a conference put on mainly for DBT users, so I do want to give a little insight into this. You know, we generally follow Fishtown's guidance on adopting an ELT process in our data transformation. So we extract all of our raw data files from source, we load those into raw as is. Then we have a separate database called analytics where we materialize all of our nice, clean data tables and views that we would like our analysts to use for reporting. But we also felt the need to build out what we call the legacy layer, which is a bunch of different databases that all contain views which pull from tables in analytics. And the only difference there is that they have different table names and different column names and a few light pieces of transformation to make the data look exactly as it did in the legacy system, which helps analysts to migrate over into Snowflake without having to worry about learning new columns and new table names in analytics. We store all of our code in one single DBT repo. The only reason I bring this up is because I know there is sort of this debate on the DBT Slack channel about, you know, should you have multiple repos for different pieces of your project? We don't think it's necessary, and it's probably a controversial point, but we think it's really easy to keep everything in one place. When you can do a control F over your whole entire data warehouse, it really helps you when you want to find how a column is being calculated, for example. We also have a few unique components of our repo that I'd like to call out. The first one is that we spent some time building out what we call raw macros. So raw macros actually help us to define all of the DDL and DML in our raw database by just running one single DBT run operation from the command line. So things like creating the file formats and external stages, tables, copy into commands, all of that. We package those up into raw macros for every single data source, and that allows us to easily build out raw whenever we want. I touched on legacy models in the last slide, but that is also a kind of unique component to our repo, which I think can help a lot if you are struggling with getting analysts to move to not only a new platform and a potentially new data model. We also spent time working specifically with Fishtown on building out a new custom materialization called Lambda views. There is a really nice discourse article on this, so I won't spend too much time talking about it, but it is essentially the way that we expose real-time data in Snowflake by unioning a table, an incremental table, and a view. Super cool work. Thank you, Amy, for all your help on that. And in addition to this, we also use our DBT repo to implement access control on Snowflake. And we also we set up a macro called apply data masking, which I'll be talking about later on today, that helps us to implement Snowflake's native dynamic data masking feature on top of our data tables and views to make them more secure. So DBT is really great and it helped us to do all of this work, but we did identify some features of DBT that could potentially use improvement. I'll preface this with saying that our project pushed DBT to its limits. Most of the issues we encountered were purely scale related, but I bring this up in this forum because I know there are a bunch of smart people watching this, and I would love to see some of these features eventually built out in DBT core. So just to give some background, our project takes about 10 minutes to compile before any models start running. That is just, it takes a little bit longer than we would have liked. And I know Fishtown is working on this, but this is currently a pain point for us. And part of it is because we have everything stored in one single repo. We know that if we break it up, we could decrease that compilation time. But overall, we want to still keep one single repo and we want to have shorter compilation times. We also would like to see a little bit more of a solution around how do we deal with repetitive code. I know macros are great. Macros allow us to work towards having a lot more drier code in our entire repo. But I'm also thinking about what if DBT could inherit docs, right? In the same way that you can inherit models and reference models and other models, I feel like docs should work the same way. It would save us a lot of time and a lot of work and would probably decrease a lot of YAML files in our repo. One of our engineers actually wrote a script to generate DBT models from an Excel spreadsheet, which helped him cut down on a lot of repetitive code that he had to write. I thought that was a really cool idea, and I feel like this functionality should exist somewhere in the DBT offerings. On top of that, native access control would be absolutely amazing. We wrote out a series of macros using DBT to grant access to different data tables, schemas, databases, you name it, in Snowflake, and we run them on a schedule in DBT Cloud. But having support for this native standard out of the box would be really great. So what's next for us? I kind of want to come back to where we started, where I started the presentation, talking about becoming a more data-driven organization. So we again spent all of 2020 like setting the base, building out our new data warehouse, and DBT has enabled us to really develop now a platform that can support all those types of use cases that I was describing in the beginning of the presentation. So in 2021, we plan to build predictive analytics using our DBT models from Snowflake. We also really want to focus on developing what we call curated data sets. So data sets that provide analysts with like the simplest, cleanest view of the data that they actually need to do their job. And on top of all of that, we really want to focus on enhancing our current data governance strategy with the goal of enabling better self-service analytics to bring more data to more people. So with that, I would like to thank everyone for listening today. Thank you for the opportunity for allowing me to share our story.